It's not every day the President of the United States is briefed on a construction machine, but that's exactly what happened after footage of a Chinese-built colossus went viral. Towering over buildings, operating with eerie precision, and completing work in record time, this machine sparked serious conversation in Washington. Was it a military asset? Was it real? The images were shocking enough to prompt urgent review by defense analysts and infrastructure advisors. What they saw wasn't science fiction, it was Chinese engineering in action. The machine in question? A massive tunnel boring system that looked like something pulled from a futuristic movie. We're talking about a self-driving, GPS-guided, multi-segmented beast designed to carve through solid rock as if it were clay. American experts were stunned not only by the machine's raw power, but by how advanced its control systems were. Sensors, real-time AI decision-making, and the ability to operate almost entirely autonomously. This wasn't just an impressive piece of machinery, it was a statement, a loud one, and it made world powers take notice. But what kind of machines could possibly follow this? Let's talk size. Machines so huge they make skyscrapers look small. Imagine a crane taller than a football field is long, lifting a load heavier than a blue whale. Sounds impossible. Not in China. The country has built construction machines so large they have to be assembled on-site because no road can transport them. These machines are redefining the limits of scale, breaking records in height, weight, and reach. Take the XCMG XGC E8000 for example. It's the world's largest crawler crane, weighing over 4,000 tons when fully assembled. This monster has lifted reactor vessels over 200 feet into the air, with pinpoint accuracy, even in tough wind conditions. That kind of performance requires not just size, but mind-blowing engineering. And it's not just cranes. The Sany SY1250 excavator is big enough to scoop up a full-size SUV in a single bucket. These machines don't just operate, they dominate their environments. They're built not for urban jobs, but for massive infrastructure, dams, nuclear plants, and entire city blocks at once. But here's the kicker. These giants aren't just tools. They're symbols of China's rising global industry, and they're showing up in places no one expected, including some of the most iconic construction projects around the world. The real question is, who's building with them? Some of the biggest, boldest engineering projects of the last decade have one thing in common: Chinese-built construction machines. From Africa's longest bridges to Latin America's newest superhighways, these machines are at the heart of the action. And it's not by accident. China isn't just exporting tools, it's exporting infrastructure. Countries across Asia, Africa, and South America are signing deals for mega projects, and Chinese construction firms bring their own equipment. These aren't backyard projects. We're talking about sea-crossing bridges, underground transportation hubs, and 30-story skyscrapers built in weeks, not months. One standout example: the Daxing International Airport in Beijing. An engineering marvel, much of its structure was made possible by machinery developed specifically for the job. Ultra-long-span roof trusses, custom tower cranes, mobile concrete mixers. It was a fleet of innovation. And the most surprising part? Many of these machines are used outside China more than inside. From Pakistan's highways to Ethiopia's rail lines, these machines are becoming global workhorses. But some of the wildest feats come from the underground, where machines face their greatest challenge: solid rock. Tunneling through mountains used to take years. Now Chinese machines are doing it in months. These tunnel boring machines, TBMs, are unlike anything the world has seen. Some are longer than a football field, equipped with rotating cutting heads the size of a house. They're designed to chew through granite, clay, sand, and everything in between, non-stop. A standout is the slurry balance TBM, which uses pressurized fluid to stabilize the tunnel as it cuts. It can move forward while controlling debris, pressure, and even seismic feedback in real time. This allows construction under rivers, beneath cities, and through unstable terrain with minimal risk. One machine, nicknamed Kaiyun, dug nearly 7 miles through complex rock formations to build a water diversion tunnel in southwest China. Engineers working on similar machines in the US admitted they'd need twice the time to attempt the same project, and double the manpower. These machines are so complex, they require their own transport teams, maintenance crews, and software engineers just to keep them running. But some of them are even starting to run without human hands entirely. And that leads us to something even more futuristic: construction equipment that drives, digs, and builds by itself. Chinese construction machines are no longer just big, they're smart. Some of the latest excavators, loaders, and pavers use real-time AI to navigate, avoid obstacles, and even adjust their behavior based on soil type. These machines don't need an operator in the cab. They drive themselves. One example is the XCMG autonomous road roller. Fitted with GPS, LiDAR, cameras, and internal sensors, it compacts roads with perfect precision. A human could never match its consistency, and if the terrain shifts slightly, the machine adapts instantly. AI guidance also cuts costs. A single operator can now manage multiple autonomous machines from a control room, watching them work in unison. And because they learn from data, they improve over time. The longer they work, the smarter they become. The implications are huge. Reduced labor needs, faster projects, and safer job sites. No fatigue, no human error, just consistent, optimized performance. And we're not talking prototypes. These machines are already being used on real construction sites. But what if you could bring the entire factory with you to the site? In the next chapter, we look at machines that mix, pour, and finish materials right where you need them, on the move. What if your construction site didn't need supply trucks? What if the materials, concrete, asphalt, even bricks, were produced right there, on the spot? That's exactly what some of China's newest machines are built to do. These are mobile plants, machines that mix, heat, and prepare materials while moving across the job site. Take the Sany HZS series mobile batching plant. It can be set up in under 1 day and begins producing concrete almost immediately. No waiting, no transport costs, and no delays due to traffic or weather. Just pour and build. Then there's the asphalt train, a series of connected vehicles that move down long stretches of highway, laying hot, fresh asphalt as they go. It's a synchronized operation, guided by sensors and GPS, and controlled by a central system that monitors temperature, thickness, and curing in real time. This kind of mobility doesn't just save time, it changes the game. Roads get built faster, remote areas become accessible. Entire job sites shrink in size because storage and transport aren't needed. The precision is so high that some of these systems are now being used for airport runways and high-speed rail beds, where even the smallest flaw can cause disaster. But how do these machines know what to do? It's time to look deeper, literally, into the hidden tech inside them. From the outside, many of these machines still look like steel beasts, loud, heavy, brutal. But inside, it's a different world. Chinese construction equipment is increasingly packed with smart tech that constantly analyzes, adjusts, and communicates. LiDAR sensors scan the ground for micro changes in slope. Thermal cameras detect material temperatures to prevent early setting or cracking. Vibration monitors make sure compaction is uniform. And these systems talk to each other. In fact, some machines operate as part of an ecosystem. A cement mixer might adjust its blend based on real-time feedback from the paver it's feeding. A crane may modify its counterweight balance in response to sudden wind changes measured by an anemometer on a nearby tower. All this data is sent to cloud-based platforms where engineers can track machine health, fuel consumption, and performance from hundreds of miles away. Breakdowns can be predicted days in advance, and maintenance becomes proactive instead of reactive. This isn't just automation, it's construction guided by data. And that's why the next frontier isn't just raw power or smart systems. It's how these machines are powered in the first place. Let's talk energy and the race to go clean. Heavy machinery has always been a gas guzzler. Diesel, oil, fumes, and noise. But China is now leading the shift toward cleaner, greener construction sites. Some of its biggest machines are being reimagined with electric, hybrid, and even hydrogen power systems. Take the XCMG XE270E electric excavator. It's powerful enough for major projects, yet silent and emission-free. Designed for urban jobs where noise and pollution are critical concerns, it runs on a lithium battery system with a full work shift per charge. Meanwhile, hybrid cranes combine diesel and electric motors, reducing fuel usage by as much as 30%. These machines can switch power modes on the fly, using clean energy when possible and fuel only when necessary. There are even solar charging systems being tested on remote job sites, providing clean power when no grid exists. This shift isn't just about the environment, it's about strategy. Countries importing machines increasingly demand lower emissions and compliance with green standards. And Chinese manufacturers are adapting fast, often outpacing Western companies still tied to traditional engines. But where are all these machines going? The answer? Everywhere. It's not just China using Chinese machines anymore. Construction equipment made in China is now working across 5 continents. From mining operations in Chile to highway expansion in Kenya, these machines are becoming a global presence, and not just for budget reasons. The appeal is practical. Chinese machines are improving in quality, packed with tech, and sold at lower prices than American or European rivals. Financing options are generous, and delivery is fast. That makes them attractive to developing nations trying to build fast and affordably. In South America, fleets of Chinese graders and bulldozers are reshaping terrain for massive agricultural expansion. In Southeast Asia, mobile concrete plants are helping rebuild after natural disasters. And in the Middle East, Chinese cranes now work on luxury skyscrapers in cities like Dubai and Doha. Even in countries traditionally loyal to Western brands, Chinese machines are showing up more often, not just as backup, but as main tools on the job site. However, this global spread brings scrutiny. Are these machines as reliable as they seem? Let's dive into some real cases where things didn't go according to plan. No machine is perfect. And yes, Chinese construction equipment has had its fair share of failures. In some cases, it's been a cracked support beam. In others, a crane collapse or a machine stalling in the middle of a tunnel bore. These incidents raised serious questions. One widely reported case involved a massive crane imported to a European port project. During a routine lift, the hydraulic system failed, leading to an emergency stop and weeks of delay. The investigation pointed to a software issue, one that hadn't been updated since the factory. In another instance, a remote mining site in Africa saw a fleet of Chinese bulldozers break down within months. It turned out the local operators hadn't been trained to use the software systems, and maintenance protocols weren't followed. But here's what's important. These incidents aren't happening because the machines are inherently flawed. In most cases, it's about integration, how these machines are introduced, maintained, and adapted to different environments. And Chinese manufacturers are learning fast. In response, they've launched global training programs, updated documentation, and established support teams abroad. So how does the West respond to all of this growing dominance? Let's take a look. As Chinese machines spread across the globe, Western companies and governments aren't standing still. In the United States, companies like Caterpillar and John Deere are accelerating their R&D programs, investing billions into automation, electrification, and data integration. But catching up is proving harder than expected. Part of the challenge is speed. Chinese manufacturers iterate quickly, releasing new models in months, not years. They test equipment in real-world conditions, often on government-backed mega-projects. Meanwhile, in the West, strict regulations and higher costs slow everything down. The geopolitical response is also growing. Trade restrictions, tariffs, and buy local policies are being used to curb Chinese influence in public infrastructure. Yet many private companies, especially in mining, logistics, and real estate, continue to import Chinese equipment because of its cost-effectiveness and availability. Europe is reacting too. German and Swedish manufacturers are shifting focus to high-end specialized machines where they still hold an edge. But the mass market? China is closing in fast. And many experts believe the days of Western dominance in construction machinery are numbered. But is China just copying and scaling existing tech, or are they actually innovating? The answer might surprise you. For years, China's industrial growth was criticized as imitation. They just copy, critics said. And early on, that was often true. Many first-generation machines resembled Western designs down to the bolt pattern. But that era is fading, and fast. Today, some of the most advanced construction machines in the world are being designed from scratch in Chinese labs. Companies like XCMG, Zoomlion, and Sany have established research centers in Europe, the US, and Japan, not just to learn, but to lead. They're filing patents, publishing papers, and winning global design awards. Chinese machines are no longer just cheaper, they're often smarter. Real-time data feedback, AI-driven load balancing, predictive maintenance algorithms. These are features not even standard in some American or European models, and they're building for the world. Modular machines that can be adapted to different terrains, climates, and project types. These aren't clones. They're evolving tools built with global performance in mind. So, what does the future look like? How far can this go? In the final chapter, we'll look at what's coming next, and what it means for everyone. If the past decade was about size and speed, the next one will be about intelligence and independence. China's construction machines are already hinting at a future where entire job sites run themselves. Autonomous fleets, remote-controlled cranes, 3D printing robots laying concrete walls. It's not fantasy. It's already being tested. Some companies are developing smart sites where every machine, from the excavator to the concrete mixer, is connected to a central brain. This system plans, coordinates, and executes tasks with almost no human intervention. Workers don't operate machines, they monitor systems. Meanwhile, energy tech continues to evolve. Hydrogen-powered loaders, battery swap stations for bulldozers, and ultra-efficient solar-powered drones for site mapping are entering real-world trials. All of this points to one thing: a world where construction becomes faster, cheaper, safer, and much more automated. So when you see a giant Chinese crane or an AI-powered tunnel digger, remember, it's not just a machine, it's a signal, a sign of where the future is headed. And the rest of the world, it's trying to keep up.